we will familiarize you with the parts of a typical turbine and their nomenclature. This is the turbine that we will be working with throughout the remainder of this course. It is a single-stage turbine with a mechanical shaft governor. The designation of this turbine is Elliot 2 BYR. We will point out the primary parts that make up this machine, tell you the name of the part, and briefly explain the function performed by the part. Let's begin with the case. The rotating assembly of the turbine is enclosed in the case, which is split horizontally, as you can see. The top and bottom halves of the case are bolted together with a sealing compound between them to prevent leaks. This is the steam inlet, where the steam is admitted to the turbine. There is a screen in this inlet to prevent the entry of any foreign material that could damage the rotor. Once the steam has passed through the turbine, it is discharged here at the exhaust flange. This exhaust flange will be bolted to an exhaust line, which will carry the steam away. Now let's take a look at the working parts of the turbine. To do so, we'll remove the case cover so you can see the rotor. As you can see, removing the upper half of the casing has exposed the rotor assembly. This particular turbine is equipped with 2 wheels, even though it is a single-stage machine, as we mentioned earlier. Both of these wheels are in the same stage, increasing the efficiency. This is one of the 2 wheels. It is mounted on the shaft with an interference fit, and these are the buckets mounted on the wheel. These buckets are made separately and then mounted on the wheel. However, this is not always the case. Some small wheels may be made with the buckets built in, or in other words, the wheel and buckets would be one piece. In most cases, though, the buckets are made separately and mounted on the wheel, as you see here. Our next part is the shaft, a very important part of the turbine. On most turbines, the wheels are heated and positioned on the shaft, then allowed to cool. As the wheels cool, they shrink and grip the shaft tightly. The shaft, wheels, and buckets are called the rotating assembly. The weight of the rotating assembly is carried in 2 bearings enclosed in these bearing caps. The bearing on the coupling end of the turbine is called the inboard bearing, while the other bearing is the outboard. After removing the bearing caps, you can see that this turbine is equipped with sleeve bearings, which are lubricated by the oil rings being pointed out. You can also see a ball bearing that serves as a thrust bearing, preventing excessive axial movement of the shaft during operation. The other 2 housings, one on each side of the wheels, are packing housings. They enclose packing designed to prevent steam leakage out of the case along the turbine shaft. By removing the packing housing, you can see how the packing rings are spaced on the shaft. These are carbon packing rings, 3-piece rings which are held together by garter springs. You'll have a chance to look closer at these rings in a few minutes. This hood over the outboard end of the turbine shaft encloses the constant speed governor. As you should recall from the last segment, this governor controls the flow of steam into the turbine, thereby regulating the speed. With the governor hood taken off, you can see the governor case, which encloses the parts of the constant speed governor. This case is heated and shrunk onto the end of the shaft. Therefore, for all practical purposes, the governor case and its contents are an integral part of the rotating assembly. This is necessary for the governor to function properly. The workman is pointing out one of the 3 weights on this mechanical shaft governor. The position of these weights are the prime factor in control of steam flow into the turbine. The workman is now pointing to the spindle, which is pushed out or pulled in by the weights you saw a moment ago. Looking from the other side of the turbine, you see that the spindle is connected to the governor lever being pointed out. The lever is pinned in the fulcrum bracket in the center, which allows the lever to pivot one way or the other. The opposite end of the governor lever is pinned to the governor valve stem. This part of the casing encloses the constant speed governor valve. The valve inside opens or closes, regulating the amount of steam admitted to the turbine. The position of the valve is determined by the action of the constant speed governor, which is transmitted to the valve through the governor linkage, made up of the spindle, governor arm, and valve stem. You'll be able to study this assembly for yourself in a few minutes. The next part we want you to see is the overspeed trip assembly. As you can see, the workman is pointing to the constant speed governor case. The overspeed trip pin is mounted in this case. All you can now see is the weighted end of the trip pin. It is impossible to show you the rest of the trip pin, since it is inside the governor case. You'll have a chance to look at it for yourself when you remove it from the case later in this course. When the turbine overspeeds, the weighted end of the trip pin you just saw is forced out of the case by centrifugal force. It then makes contact with this trip plunger, pushing it down against the end of the trip lever, shown at the bottom. As the trip pin forces the plunger down against the trip lever, the lever pivots on this shoulder bolt. As the trip lever tilts, these knife edges disengage, releasing the resetting lever on the right from the trip lever on the left. Once the knife edges disengage, the resetting lever is pulled down sharply by a spring until it reaches the position shown here. The resetting lever is now in a tripped position. The resetting lever has slammed the overspeed valve shut. The valve is located inside the casing, in the general position indicated by the workman. Therefore, the position of the trip pin in the governor case has set off a chain reaction that has shut off the flow of steam to the turbine. As you recall, this overspeed trip mechanism is an emergency safety device that operates only when the turbine accelerates too much over the operating speed. The lever the workman is now pointing out is called the auxiliary resetting lever. It is used to assist in resetting the resetting lever after it has been tripped. The steam pressure against the overspeed valve often makes it very difficult to reset the resetting lever. The auxiliary lever makes it easier, as you will soon find out. The only major remaining parts we want you to see are in the bottom of the turbine case. Therefore, we will remove the rotating assembly to make it easier for you to see them. These are the nozzles we told you about in the last segment of this course. They are mounted in a nozzle ring in the side of the casing, as you can see. The steam enters the casing through these nozzles at very high velocity and strikes the buckets of the first wheel. After the steam leaves the buckets of the first wheel, it enters these reversing buckets, which redirect the steam before it hits the buckets on the second wheel. In other words, these reversing buckets are positioned between the buckets of the two wheels. These reversing buckets should not be mistaken for a diaphragm. Reversing buckets are used within a stage. Diaphragms are used between stages. This is the only remaining part of this turbine with which we will acquaint you in this segment. This is a sentinel valve. It is designed to warn you if the steam pressure in the case exceeds safe operating levels. This valve is only designed to warn you. It is not meant to be a relief valve. That completes our brief look at the construction and nomenclature of this particular turbine. Needless to say, there are many other parts in the turbine, but we have covered the major ones with which you must be familiar. From this point on, it is a simple matter to refer to the manufacturer's manual if you have any questions. Here's something else to keep in mind. Since turbines will vary somewhat, the construction and nomenclature of their parts will also vary. This means that you will have to refer to the manufacturer's manual to determine the correct name for each part. This is most important when ordering replacement parts, since you must know the correct nomenclature for the part before you can communicate effectively with the supplier. You'll soon find that the names of the parts will vary considerably more than the actual construction of the parts. We'll be back to show you how to take this turbine apart after you complete exercise number 2 in your workbook. During this segment of our course, we will disassemble the Elliot 2 BYR turbine that we worked with in the last segment. The procedure we will be showing you over the next few minutes incorporates safe and effective methods approved at most plants. In some cases, it is not necessary that each of the steps be performed in the exact order we present them. However, you should consider any change in procedure very carefully, since it could cost you more time and trouble than it's worth. First, assemble the required tools, equipment, and supplies you'll need for the job. As you can see, we will be working with a turbine that has already been removed from service and sent to the shop. The procedure we will show you is in-shop and does not include field work. Next, put on the personal protective equipment that is recommended by your plant. Don't take chances. You could hurt yourself badly if you're not careful while working on this turbine. Cleaning the exterior of the turbine prior to taking it apart is considered good practice. This will remove dirt that could fall into more sensitive parts as you remove them. Use the cleaning method that is approved by your plant. After the turbine is clean, drain the lubricating oil from both of the bearing housings. Dispose of the oil in accordance with your plant regulations. To remove the coupling from the shaft, you must first loosen the set screw, as the workman is now doing. Then, attach a puller to the coupling and remove it from the shaft. Take special care not to damage the shaft center during the process. Before going any further with the disassembly, remove the sentinel valve from the turbine and arrange to have it inspected, repaired, and reset if necessary. The next step should be to match mark parts of the turbine so they will be reassembled correctly. This would include bearing caps, packing housings, and even the turbine case cover. If you have any doubts, match mark it. Now remove the cap screws holding the inboard packing housing to the turbine case. Place the cap screws in a container so you won't lose them. Once the cap screws are all removed, raise the packing housing straight up as the workman is now doing. The housing is being removed in this manner to prevent possible damage to the carbon packing rings. After the inboard housing is removed, repeat the procedure for the outboard packing housing. Actually, it makes no real difference which of these housings is removed first. Here's something to remember. It may be necessary to pry the housing away from the casing, using the pry ears at the upper halves of the housings. Your instructor can show you how this is done if necessary. Our next step will be to remove these carbon rings from the packing housings. However, it's extremely important that you remove them very carefully, and that you keep them in the order in which they are now installed. In other words, if we reuse these rings, we'll want to put them back in the same slots they've come out of. The first step is to unhook the garter spring and slide it out of the housing, as the workman is now doing. After the spring has been removed, the workman rolls the 3 segments of the packing ring out of the housing. Again, he is being very careful to prevent damaging them. He then reassembles the 3 parts of the ring, making sure the segments are matched properly. The spring is then placed in position to hold the packing ring together. The rings are then stored in a protected area in the exact order in which they were installed in the packing housing. Use whatever method works best for you, but just make sure the rings go back in the same grooves from which they were removed, and be very sure that the ring segments are assembled correctly. The next step is to remove the cap screws holding the casing cover to the case. There are also dowel pins that will have to be removed from this horizontal joint before the casing cover can be lifted off. After the cap screws have been removed, the workman fastens a shackle to this eye bolt in the casing cover. Remember, this eye bolt is to be used only to remove the cover, not to lift the entire turbine. He then lifts the casing cover very slowly, checking frequently to be sure it is not coming in contact with the rotating assembly inside. The cover must be lifted straight up when it is removed. After you have cleared the top of the wheels, set the cover to one side. Before going any further, the workman measures the clearance between the nozzle ring and the blading of the first rotor. The clearance should be approximately 1/16 of an inch. If there is any doubt, check the manufacturer's manual for the turbine. Now we'll be disassembling the bearings. First, remove the cap screws from the bearing cap. The workman is starting with the inboard bearing, although this is not necessary. Before removing the cap from the bearing, the workman must make sure that the liner is not sticking inside the cap. He lifts the cap slightly and pries the liner out of the cap as shown. This will prevent damage to the oil rings, since the rings are held by the upper half of the bearing sleeve. After the cap is removed, the workman lifts the oil ring with one hand and slides the top half of the bearing liner out. He then labels the bearing with the word inboard, so it cannot be confused with the other bearing. Next, we'll remove the outboard bearing cap. But before doing so, it will be necessary to unhook the speed changer tension spring from the bracket on the bearing cap. The main reason for doing this is just to get the spring out of the way. Then remove the cap screws from the bearing cap. Lift the cap slightly and pry the liner out of it before removing the cap. As with the inboard bearing, the workman lifts the oil rings with one hand and slides the bearing liner out. Don't forget to tag this bearing as being outboard. This is the rotor locating bearing that we mentioned earlier in this module. It is designed to limit axial movement of the turbine shaft during operation. Our next step will be to measure the lateral clearance between this bearing and its fit. The workman is now measuring the clearance to be sure it is within manufacturer's specifications. This is a very important measurement. The speed changer is next to be removed. To do so, the workman removes the hand wheel without changing the position of the jam nut being pointed out. After the hand wheel has been removed, it is a simple matter to slide the speed changer stem and the tension spring out of the